other part that's come in that is going to be new, that's not really new, but is now much more exposed and actually much easier to run with and more cost effective, is streams. So we always used to laugh, say with like, show my age, but with like the desktop, you didn't really want the streams crossing. It always looked very, very cluttered. But now we can actually start to manage data streams much more efficiently in FME. So the big reason for this is sensors. Sensors are one of a huge explosion. IoT devices, there's an awful lot of content now coming in. That all data comes in more or less real time. So it's a stream of information. And that doesn't traditionally lend itself to, a workspace running on a schedule. Needs to be faster. So FME's always had the ability to actually be able to listen as a constant flow of data, but streams really just solidifies that implementation, makes it easier to manage, to see what's going on. And then with dynamic engines, makes it cost effective. And it's not just sensors. So we always think of sensors with these things, but you can see there's business applications, airline reservation information coming in, insurance claims, telco data, IT network logs, anything that's basically high frequency data. So SCADA is always the typical one that people will look at, but there's an awful lot of other system information that's very, very fast that flows through. And you can break this down in FME on time windows. So there's a new time window transformer. So if you've seen it or see it and wonder what it is, it basically lets you break down one of these raw unbounded streams into nice discrete blocks. It might be every 10 seconds, 30 seconds, a day, or whatever, to actually manage that information a little bit more sensibly within the workflow. The other one obviously is tracking. Loads of people have probably heard me talk about this in the past. We stuck a GPS device on that little van on the bottom right-hand corner there. When it broke the geofence, it would then send us a text message. And we were using this kind of stream stuff. This was 7, 8 years ago. Conceptually, it's exactly the same. It's just now a lot neater to work, and it's much easier to implement this solution now than it was back then, because we've got this streams of information coming in, which is pushing them against a buffer. That triggers the alert. That's nice and simple. But actually, the fact that we have an ease to set up in the interface, but also dynamic engines, actually makes this cost effective to implement now. And the other one that's obviously there, we've talked about, is sensor buoys. So we've been looking at collecting information on sensors. So this is Dublin buoy. It floats around off the coast of Dublin, just outside of Dunleary. It's recording temperature, wave heights, and all other sorts of weird and wonderful marine information. That's generating a message. And when we were talking about those RabbitMQ, the Azure message streams, that's the sort of thing. It'd send its data up into one of those message queues, and then FME listens for it. So in this case, we're using Amazon's SQS. So it basically listens and pulls a message down every time that buoy sends a sensor update back into the system. So as it sends that sensor update, we can pull it down and then process that and then log that within our database. So it's very, very easy to build up these workflows now using these platforms. So just to give you a brief idea for that one, we've got our sensor stream, we've got this new streams option. You can see build stream. If you ever saw an FME, there was a run till cancelled option. That run till cancelled option is basically streams. It's the same idea, and it's what we were using previously with that coffee example. It's now just made much more obvious within the workflow, and it's easier to assign the jobs and engines as well now. It's always a little bit more tricky to do that. So you can see here we've assigned that dynamic engine. So that engine is now associated with this particular sensor stream. And the challenge in the past has always been that once you assigned it, you locked that engine out and it couldn't do anything else. With the dynamic engine, we're not locking up the engine. I'm only paying for the processing hours I'm using. So even though I've got an engine there sat processing it, I'm not locking out a full FME engine. I'm only going to have to pay for those times when those messages come through. So, what would have been, probably an uneconomical solution in the past, is now very, very simple. And you can see we've got our credit hours there that we're calling down to run. So it makes these sort of stream data loads much easier to work with.